In this example, we want to illustrate a multi-step game and how we might compute some expected values. So the way this game is played is one ball will be chosen at random from an urn that contains one red ball, one white ball, and one blue ball. So if it's a red ball, the player immediately loses $20. If it's a white ball, the player flips a coin. Heads wins $10, tails loses $10. And if it's a blue ball, the player will roll a four-sided die and then win 5 times the number of the die. So we're going to start out by drawing a probability tree for the game. Then we'll compute the probabilities of each of those outcomes and determine their values. And then finally get the expected value for this game altogether. Okay. So I've mapped it out here already. Here's the tree without any of the probabilities listed, but once again, if there was red, we immediately lose $20. If it's white that gets pulled out, we will flip a coin. If it's heads, we win $10, tails, we lose $10. And if the blue ball gets chosen, we roll a four-sided coin, and then you win 5 times the value of your roll. So let's add in the probabilities here. Since there were 3 balls that were equally likely, I'm going to put 1/3 on each of these branches. Then, heads and tails. It's a fair coin, so it's 1/2 for each of those branches. And then, a four-sided die will be 1/4. What would be the probability of each of those outcomes? Alright, so I think I see 7 different ways that this could end. So the probability of a red ball, well, 1/3 of the time that will happen. The probability of white followed by heads is 1/3 times 1/2, or 1/6. The probability of white followed by tails is 1/3 times 1/2, or 1/6. The probability of a blue followed by a 1 is 1/3 times 1/4, or 1/12. And each of the other outcomes here will be the same probability. Each of them will be 1/12. Okay, so those are the ways that the game can end. Now we want to find the value of each roll, or each outcome. So the value of red, we said that we would lose $20. So it's -20. We'll stick the dollars on later. The value of white ball with heads was $10. The value of a white ball with tails was -$10. The value of a blue ball with a 1, well, we said we would get 4 times. Ooh, better peek again. You would get $5 times the number on the die. Alright, so if we roll a 1, we're going to get $5. If we roll a 2, it would be $10. If we roll a 3, we get $15. And if we roll a 4, we get $20. Excellent. Now that we have the values and the probabilities for each of the possible outcomes, we can find the expected value for the game. The expected value, I'll just write game here. Often we'll assign it a variable, like let x be the value that you get out of this game, but I didn't do that. The expected value of the game is, now we do the probability of red times the value of red, plus the probability of white heads times the value of white heads, plus the probability of white tails times the value of white tail, plus the probability of a blue 1 times the value of a blue 1. We continue on, plus the probability of a blue 2 times the value of a blue 2, plus the probability of blue 3 times the value of blue 3, plus probability of a blue 4 times the value of a blue 4. Okay, so now we actually stick in some numbers, but we've already computed them up here. It's just a matter of sticking them in. 1/3 times -20. So that was the probability of red times the value of red. Now we go the probability of white heads. So that was 1/6 times 10. We then go to probability of white with tails. That was 1/6 times -10. Plus, and the probability of the blue 1 was 1/12, and its value of the blue 1 was a 5. 1/12 of the time we get a blue 2, and the value is 10. 1/12 of the time we get a blue 3, the value is 15. And then 1/12 of the time the value will work out to be 20. So now we can actually crunch these numbers. So you get -20/3 plus 10/6 minus 10/6 plus 5/12 plus 10/12 plus 15/12 plus 20/12. Alright, I see that these two will just add to be 0. So now -20/3, I'll just leave for a moment. I see 5/12 plus 10/12 plus 15/12 plus 20/12 is 50/12. So if we want to add those two, we can get a common denominator. So maybe multiply by 4/4. And I'm going off the bottom of my page here. We'll get -80/12 plus 50/12, which works out to be -30/12, or if you do long division, we'll find that that's -2.5. So in this game, the expected value is -2.5, and I'm going to stick the $ in there because we were given units in this problem. But that's how to handle a multi-step game and find its expected value.